Dear students, welcome to an exciting problem solving session on zero initial velocity problems. In the previous video, we are dealing with the function f of x. It might be a trigonometric like v naught sine cube pi x by L or simply v naught sine pi x by L, etc. On the other hand, it is kx into L minus x or simply x or x square, etc. In today's session, we are going to see the problem which does not give any information about f of x. Let us go into the problem. A tightly stretched string whose length is L. So one side is x equal to 0, the other side is x equal to L. Now we are lifting the string to an height h from the midpoint. So that means we are pulling out the string like this. So it is very clear. Now I am holding the string at this point. So there is no initial velocity. There is an initial displacement. So this problem is a zero initial velocity problem. But the problem is they don't give f of x, but some information is given about the f of x in terms of theoretical content. So let us solve the problem. As usual, our step 1 is diagram. Now let us consider the string, mark the two ends as A and C. Now it is lifted to an height h and mark this point as B. So the height is h. Now let us write the coordinates 0, 0, L, 0 because the length is L. Here at the midpoint it is going to be L by 2, 0. Since the midpoint of the string is lifted to an height h, so this coordinate is going to be L by 2, h. Now let us keep the diagram as it is. We will use this at the end. Whenever we draw the diagram, we know the left hand side we have to write at 0, t. Any time t, this end is fixed. There is no displacement. Similarly, at the other end, for any time t, it is going to be fixed. There is no displacement. Next step 2, 3, 4 all are as usual. Let us write the wave equation. Y double t is equal to a square y double x, where a square is t by m, tension divided by mass per unit length, and we take the most suitable solution from the previous videos. You know all the basic. Now we have to write the initial and boundary conditions. Since the problem is zero initial velocity problem, velocity is going to be 0 and displacement is non-zero. From the figure, it is very clear. We have two endpoints A and C. This is going to be my first boundary condition, and at the point C we have the second boundary condition. At two endpoints there is no displacement. So let us write the boundary conditions. For any time t greater than 0, y of 0, t is 0 and y of L, t equal to 0. An initial condition, 0 initial velocity problem. So there should not be any initial velocity. And then finally, there is a initial displacement. The only unknown function in this problem is f of x. We don't know what is f of x. It doesn't matter. Let us solve the general problem. At the end, specifically, we can find f of x. So let us take the equation 1, apply 1 in 1. When you apply this, cos 0 is 1, sin 0 is 1, and then it is very clear that c into cos lambda at plus d into sin lambda at cannot be 0. If this is 0, the whole term is 0. So the only option here is a is 0. As usual, I said apply and substitute. Substitute a equal to 0 in 1. We get a new equation. Now take this as 2 and apply 2 in 2 and we can find something new. When I apply 2 in 2, I'll get like this. Left hand side 0, and already we just discussed c into cos lambda at plus d into sin lambda at cannot be 0, and b also can't be 0 because already a is 0. If b is 0, then the whole term is going to be 0. So the only chance is sin lambda L is equal to 0. We know that sin n pi equal to 0 for any positive integer. Therefore, we can find lambda is equal to n pi by L. Let us substitute this lambda in 2. When I substitute lambda in 2, we get a new equation 3. But our third boundary condition is yt of x, 0 equal to 0. It is in terms of velocity. Now y is in terms of displacement. So let us differentiate this equation 3. For my convenient, I'm keeping this as 3 star. So I'm partially differentiating 3 with respect to t, and we can get this because this term is constant. Cos n pi a t by L is minus sin n pi a t by L, and n pi a by L is constant. Similarly, differentiation of sin is cos, and we have to multiply the constant n pi a by L here. Now applying the initial condition, that is yt of x comma 0 equal to 0 in 3 star, we get 0 is equal to b into sin into d into n pi a by L. Now we have to check n pi a by L is constant. This can't be 0. In the previous step only, we find lambda equal to n pi by L and we substitute here. So this is also can't be 0. Since already a is 0, if we make b also 0, then the whole problem will become 0. So the only chance is we have d equal to 0. Therefore, substitute d equal to 0 in 3. 3 star is for my convenience. I have took the content and solved it. Now substitute d equal to 0 in 3. We get this. Now it's time to write the most general solution. I am taking this Bn as capital BC. Now see, up to this everything goes well, but the problem is I don't know what is my f of x. Now apply y of x comma 0 is equal to f of x in 4. Then we get f of x as summation n equal to 1 to infinity bn sin n pi x by L. Now this looks like a half-range Fourier sine series. We know the formula for Bn. To find Bn, we need f of x. Let us go back into the step 1, that is diagrams. Let us find f of x and then we can integrate this problem. From the figure, it is very clear the string is lifted at an height h from the midpoint. So now we have two lines, that is 0 to L by 2 and L by 2 to L. Now let us find 1 by 1. How to find the equation of this very basic question? Everybody will remember if I show the formula. 2-point formula. Now I am going to apply this formula to get the equation of AB and BC. So along the line AB, we can see the points are 0, 0 to L by 2, h. Now let us write the points one by one and then substitute here. So y minus 0 divided by y2 is h, y1 is 0 is equal to x minus 0 divided by x2 is L by 2 minus 0. Now simplification is going to be very easy. Y by h is equal to 2x by L. So y equal to 2hx by L. Done. So now along the line AB we found. We have to do the same thing for along the line BC. Along the BC, we will take this as x1, y1 and the next point as x2, y2. Substituting in the point formula, we get y minus h divided by minus h is equal to x minus L by 2 divided by L minus L by 2. Denominator, when we simplify, we will get L by 2. When we take to the numerator, it will become 2 by L into x minus L by 2. Next we have to take this minus h to the other side and then we have to take this minus h to the right hand side, that is y is equal to h. Now multiply this minus 2h by L inside, we get 2h by L into x minus into minus plus 2h by L L by 2, that is y equal to h minus 2h by L x plus h. Therefore, y is equal to 2h minus 2h by L x. Now we can take 2h by L in common. So in the first term we get L, in the second term we get minus x. That is my y. So we found along the line AB and along the line BC. We have to represent like this. F of x is going to be 2h by Lx between 0 to L by 2 and it is going to be 2h by L minus x between L by 2 to L. Finally, we found f of x and we write the half-range Fourier sine series formula. And now we are going to find the answer, that is Bn. But f of x is splitted into two intervals. From this, I can see 2h by L is common in both integral. We can take this outside. We have two integrals, that is 0 to L by 2. The other one is L by 2 to L dx. I am going to take the first integral as I1 and the second integral as I2. Now we have to evaluate this I1 and I2. My capital I1 is integral 0 to L by 2 x sin n pi x by L. We did this many times from unit 2, so we are thorough. We have to use Bernoulli's formula. U is x, u dash is 1, u double dash is 0. When we take dv, we have sin n pi x by L dx. V is minus cos n pi x by L divided by n pi by L. Then V1 is minus sin n pi x by L divided by n pi by L whole square. Now we have to use Bernoulli's formula. We know the Bernoulli's formula is uv minus u dash v1 plus u double dash v2 etc. Since the remaining terms are 0, we'll be getting only one term. So the Bernoulli's formula is integral u dv is equal to uv minus u dash v1 plus u double dash v2 etc. Now let us substitute this in the Bernoulli's formula and taking the denominator to numerator, which is easy for me to solve the problem further. Now it is easy to see when I apply the lower limit, sin 0 is 0, cos 0 is 1, but we have x here. When I put x equal to 0, therefore in both the cases the lower limit value is 0. So only we have to find the upper limit. So when I substitute the upper limit, we get L by 2 into L by n pi, I am taking the constant, then minus cos n pi by 2. Now minus into minus plus, we have L by n pi whole square. When I substitute this L by 2, we will get sin n pi by 2. Now simplifying this further, we get minus L square by 2n pi cos n pi by 2 plus L square by n square pi square sin n pi by 2. Next, in the similar way, we have to solve for I2. The only change is L minus x instead of x, and instead of the limit 0 to L by 2, here we have L by 2 to L. Now let us take the same equation. The only change is going to happen in the left hand side. So my u is going to be L minus x. A differentiation of u is minus 1 and differentiation of u dash is 0. Now again we have to map this in the Bernoulli's formula. Now rewriting this, we can get the content. Now let us see when I substitute the upper limit and we get sin n pi. For all positive integer, sin n pi is 0. On the other hand, we have L minus x. If you substitute x value as L, then we get L minus L, that is 0. So in both the cases, upper limit is 0 here. Therefore, I will write my upper limit is 0 and I am going to apply the lower limit. When I apply the lower limit L by 2, L minus L by 2 is L by 2. I'll take this minus out and we have already L by n pi, then cos n pi by 2. The second term, minus into minus into minus, that is minus L square divided by n square pi square sin n pi by 2. Therefore, my capital I2 is L square by 2n pi cos n pi by 2 plus L square by n square pi square sin n pi by 2. Now let us add this I1 and I2. Let us recall I1. Substituting in the final answer, Bn is equal to 4h by L square I1 plus I2. Just adding this 2, we can cancel this cos term. Only sin term exists and we get 2L square by n square pi square sin n pi by 2. Now substitute the Bn in the most general solution. Further simplifying this, we get the final content 8h by n square pi square sin n pi by 2. This is my final answer, students. So this problem is little different. We have to find f of x when the theoretical content is given to us, and up to most general solution the procedure is same. The extra thing, you put little effort to find f of x and then find Bn. Hope you understand.
Thanks for watching. Hope you found this video helpful. Subscribe to our channel and share it to your friends. See you in the next video. Bye bye.